This video is all about the chain rule, which is how we differentiate where we've got one function inside another function. So first let me show you a few examples of what that might look like, and then I'll show you how we use the chain rule to differentiate. So in all of these situations here, we would need to use the chain rule, because that's first situation, I've got the 3x minus 1 inside the power 4 function. B, we've got the 3x inside the sine function. C, we've got the 5 minus 2x inside the square root function. D, we've got the x squared minus 4 inside the cubed function. E, the 4 and the 7 don't matter so much, but we've got the x squared inside the exponential function. And then on F, we've got the 3 plus 2x squared inside the logarithm function. So that's how you can tell when we're going to need to use the chain rule. Let me now show you some examples of actually how we do that then. So this first example, I'm going to show you the full method of the chain rule, and then I will talk about a shortcut that we can use. So this is one of the examples we saw a moment ago. We've got the x squared minus 4 inside the cubed function. So what I'm going to do is I'm going to use a substitution. I'm going to say let you could use a different letter if you wanted to be the inside function, the x squared minus 4. That then allows me to rewrite the original expression. So y equals the x squared minus 4, which is now u cubed. So I've just swapped this to be the u. That then allows me to differentiate that y function with respect to u. When I differentiate u cubed, I get 3u squared. But I don't want to give my answer in terms of u, I want to give my answer in terms of x. So I need to think back, what was u? It was the x squared minus 4. So I'm going to change that to be 3 lots of the x squared minus 4. So far I've found dy by du, which I don't want. I want dy by dx, the gradient function. So what I'm then going to do is I'm going to come to my substitution, the u equals x squared minus 4, and I'm going to differentiate that with respect to x. So differentiating the x squared, we'll get 2x. Differentiating the minus 4 will be 0. So I found that du by dx is 2x, and I've found dy by du is 3 lots of x squared minus 4 all squared. Now I'm going to use the chain rule, which says that dy by dx is equal to dy by du multiplied by du by dx. So that is the chain rule. The reason why we call it the chain rule is because these du's here would cancel out and just leave me with the dy by dx. So what those du's do is they create a chain that link these derivatives together, hence why we call it the chain rule. The dy by du, that's the 3x squared minus 4 all squared. So that's me just replacing this with this. The du by dx is this. So I'm going to times that by 2x. And then I can simplify a little bit because the 3 times the 2x is 6x. And I've got the x squared minus 4 squared. And that is my gradient function. So that's me doing the chain rule, the long full method. However, there is a shortcut that we can use, and it is important that you get used to using the shortcuts, because the chain rule is just one rule that you're going to learn over the next few lessons. And you're going to need to use the chain rule as part of other rules. And if you're using this full long method, it could become really quite confusing. So, the shortcut. First of all, like I said before, recognizing that we've got the x squared minus 4 inside the cubed function. In order to differentiate this was me differentiating the cubed function, the outside bit. Differentiating the cubed gave the 3 lots of the x squared minus 4 squared. So this was me differentiating the cubed function. The inside stays exactly the same, the x squared minus 4. Then I multiply by the derivative of the inside function, the derivative of the x squared minus 4. So just to repeat one more time, I look at the outside function first, which in this case was the cubed, and I differentiate that. So I get 3 lots of the whatever's on the inside, in this case x squared minus 4, so 3 lots of that squared. I then multiply by the derivative of the inside function, which is the 2x. So the way we would look at this question with the shortcut, this is the inside, this is the outside. Straight away, dy by dx, so we differentiate the outside function, differentiate the cubed, so we get 3 lots of something squared, the inside stays the same, and then I'm going to multiply this by the derivative of the inside. The derivative of x squared minus 4 is 2x, and then we simplify, and we're done. Next example, we've got 3x inside the sine function. So differentiate the sine function first. Sine differentiates to be cos. The inside stays the same. Then we're going to multiply by the derivative of the inside function. The derivative of the 3x is 3. So this was me differentiating the sine x, this was me differentiating the 3x, and simplifying that, we get 3 cos 3x, and we're done. Next example. We have got the 5 minus 2x inside the square root. Now we know to differentiate the square root, we're going to rewrite that as a power of 1/2. We've got 5 minus 2x inside the square root function. So we're going to differentiate the outside first. So differentiate the square root function first, which means we're going to times by 1/2 and take 1 away from the power. The inside stays the same. And now we're going to multiply that by the derivative of the inside. The derivative of 5 minus 2x is minus 2. So this was me differentiating the square root part with the inside staying the same. This was me differentiating the inside. And then we can simplify that a little bit, because the half times the minus 2 is minus 1. And then this minus 1/2 power means that I can actually rewrite that on the denominator like this. Or alternatively, you could instead of having the half power, we know that means square root, so I could rewrite that like that if I wished. Example 4 notes that we've got 3 plus 2x squared inside the ln. So we're going to differentiate the ln first because it's the outside function. We know that when we differentiate ln, we get 1 over. The inside is going to stay the same. Then we have to multiply this by the derivative of the inside function. The derivative of 3 plus 2x squared is 4x. So this was me differentiating the ln with the inside staying the same. This was me differentiating the inside. I multiply them together by the chain rule. And then we can simplify that because the 1 times the 4 is 4x. And there we go. Last example now. We have got y equals cos squared 5x. Now we need to remember what this squared there means. That means the same thing as cos 5x squared. They are exactly the same thing. The only reason we write the squared here with trigonometry is so that we don't have to bother keep writing out these brackets every single time. So those mean the same thing. So thinking of it in those terms, we can now notice that we've got cos 5x inside the squared function. So we're going to differentiate the squared function first, because it's on the outside. So we'll times by the 2, the inside stays the same, and we take 1 away from the power. So this is me differentiating the squared function. I now have to multiply that by the derivative of the inside. The derivative of cos, well, the derivative of cos is minus sine. So I'm going to multiply this by minus sine 5x. And notice that actually in this question here, when I'm differentiating the cos 5x, I've actually got a chain rule here as well. So this is me differentiating the cos aspect of it. And I need to multiply that by 5 because of the 5x aspect of it. So this question, what we've actually got is we've got a double chain rule. We've got the 5x inside the cos that is inside the squared. So I dealt with the squared first, keeping the inside the same. Then I dealt with the differentiating the cos, which gave the minus sine. And then I dealt with the 5x by timesing by 5. And all of that is going to simplify to be minus 10 sine 5x times cos 5x. Now we could leave our answer like that, or you might notice that this looks similar to the sine double angle. Remember, we know that sine 2a is equal to 2 sine a cos a. So in this case, we could rewrite 2 sine 5x cos 5x as sine 10x. So the minus 10, I'm going to rewrite that as minus 5 times 2 sine 5x cos 5x. And then this can be replaced with this. These last couple of steps are not so important. As long as you understand and can get to this stage, that's the important thing about the chain rule.